and welcome into yet another live stream, and today we will be... I've set this up. Isn't that just lovely? I know it's a bit loud, but that's because, you see, right now, center of frame, oh, the center is actually surprisingly far off. I know it's a bit loud and I do apologize. Hi the Ta, hi the Moro, hi the unholy thingable, hi the Mashrit. Hi everyone, welcome. Damn it, it's stuck. Open up. There we go. IRL stream, yes indeed. IRL stream indeed. And good morning to you all. Good morning, good morning. How are you all doing on this fine day? Isn't it fun? Hi there everyone, how are you all doing? I hope you can hear me well. I hope there aren't any problems. I don't think they are. Everything seems to be working fine. I did a basic setup. Loving the surface thing. Yeah, that's the technical math thing. I have set up the basic thing for the live streams, and that's why right now we have so much space to work with. Oh, isn't this just beautiful? I can move the microphone a bit closer. Hi, The Swim. Welcome, welcome, welcome. And welcome you all to this live stream. And today, we won't do anything too crazy, actually. We could start going crazy, but we won't do anything too crazy. We'll do some simple stuff. That's because, you see, I have a lot of boxes. A lot of boxes. A lot of boxes with... Please put the coffee in the middle of the hexagon. Okay, I can tell why it was... Hold on. Oh no, the only, like, circle big enough is right here, but that's actually off the table. It may not look like it, but this is actually off the table. No, that's very unstable, but it looks good, so I'm gonna leave it there for a second. So, here's the deal. I've got a lot of boxes, right? When I say a lot of boxes, I mean a lot of boxes. And they're all full. They're filled to the brim with the fun science contraptions and chemicals and such and such. And today, I thought, today on stream, we might as well unpack them. Because why not? I hope that this angle is large enough for me to unpack, and actually, I hope that... So boxes like these, you know, just standard typical boxes. This is empty, but for example, right here, I have resistors. Look at that, that's useful. That's inconvenient. It's resistors. I should probably lower the... Please. There we go. The shutter speed. Loot box opening stream. It is exactly. It's loot box opening stream, except these are all just my own loot boxes. No, but not all of them are boring. So, for example, this box right here. Oh damn it, my axe is not sharp anymore. That sucks. My axe dulled on me. Damn it. For example, in this box right here, it's a bit of a bigger one, but this is from my absolutely beloved Varkem. And you might be wondering, oh, what is it that comes packaged in such a neat way, right? Peanuts to the brim. I love the way they package them, by the way. It's great. I know that it's kind of maybe difficult to see, so let me pull out the actual things, because they are actually urea. This is a bit too wrapped for me to tell, but I'm guessing that's acetone. I think that's acetone. Let me just... Oh, that is wet. Oh, that's wet. Oh no, that's ethanol. Well, what fool I've been. Oh yeah, it smells like alcohol. No, that makes sense. Don't hate it when you booze. It's ethanol. I'm not kidding. That's what it is. Just ethanol. We can set it on fire if you want. Hold on. I kept my burning plate precisely for this situation. Wrong, sulfuric acid. No, I have sulfuric acid in another box, don't worry. I never mistake my sulfuric acid with ethanol. Alright. Kids, oh yeah, and there's one more thing by the way, but that's just citric acid. Right here, this is just citric acid, so that's kind of boring. Kids, don't do as I do as I don't. Setting ethanol on fire in a... There, see? It's ethanol. Simple as it could be. Oh boy, 7 minutes in and we already have a fire in my kitchen. That's good. We're making good time, if anything. If anything, we're making good time. Hello, Megit, how are you? Hi there, comedian. I'm doing well. Oh yeah, we need to be careful not to burn the mat, actually, because I don't think it can handle high temperatures all that well. And actually, ethanol burns surprisingly hot, so, you know, snort the smoke. It's ethanol. It doesn't actually... It burns relatively cleanly, all things considered. That was actually the box that I ordered before. It's a bit silly because I already had ethanol. That's what I was setting up on fire. Hi Jose, hi, welcome. That's what I was setting up on fire in my previous videos, so I've already had it. This is just more in case I need it. There, it's gone. I should move the camera a bit. Get over here. Don't mind me, I'm just gonna grab you by your neck and then twist. There we go. Hope you didn't mind that. I suppose I should have asked first. Nothing like some chemicals in my kitchen. I'm just kidding, my kitchen already has so many chemicals. But yeah, today on stream I mostly want to test this out. This setup, see how it goes. Maybe just open windows nearby. You know what, I actually closed off a window yesterday. Probably opening a window would be too bad an idea. There we go. Some of your viewers are into that, don't act stupid. I imagine that an internet's holding camera. Yeah, exactly. When I wanna twist it, I just grab the intern by the neck and like twist. There we go. And that usually fixes everything right up. So you know, that's convenient. That's really convenient. My burning plate. This is one of my favorite utensils, by the way. It's a plate. That's it. That's all there is. This is just a plate, and it's one of my most used tools. It's nothing. It's not a special plate, by the way. It's normal kitchen plate that you would get from IKEA or something. There's nothing special. I just like it a lot. It's a plate. I am running a bit low on space in my kitchen. Oh yeah, did I mention? I'm streaming from my kitchen because, well, naked. I think you might be on the spectrum. Yeah, visible light spectrum. You got that right, baby. What is this box? Oh, it sounds full of goodies. I am just thrilled to find out. Oh, you can't see me twist my axe, never mind. Damn it, my axe is dull. Oh. Okay, this is the one box I cannot show you because this is for the most... This is for the secret video. This is box full of stuff for the secret video. So I cannot show you that actually. But what I can show you is... Alright. I would like you all to play a game. Let's play a game called Guess That Chemical. Your turn. Guess that chemical. What is that? What do you think that chemical is? If you had to guess. Go on, everyone, give me your best guesses. Calcium salt, stadium nitrate, sodium. Alright, tempting. It's actually sulfur. This is sulfur. Sulfur powder. Yeah. Next round. Guess this chemical. What do you think this chemical is? You can't even see it. This is just pure guess. Pure guessing. Pure guessing power. Wrong! I didn't see the answers yet, but copper sulfate? Wrong! Everyone is wrong. This is actually sulfur. I have 1.5 kilograms of sulfur. These are both these are sulfur. And and to be honest, I don't really need it. I don't know why I bought it actually. This is 1 kilogram, if I'm not mistaken, possibly more. Hold on, I'm just looking for my boxes. Actually, everyone watching right now, what should we do today? What should we? Let's make a poll. How about that? Let's do a democracy. We all like when we do a democracy, don't we? We all like when you do a democracy. What should we do today? Snort it. I'm not snorting sulfur. Not again. Fool me once. Shame on you. Fool me twice. And that's really unhealthy for me. I'm just gonna add in work on the video, just because, why not? Snort some, become golden Princeton. Okay, the poll is going, everyone. The poll is away. You decide now what we should do. Make it. What keyboard do you use? I use a black one. Next question. Research electricity. Is that really what you want? No, never mind. Make some circuits using integrated circuits. Is that 60%? Ooh, this is gonna be close. This is gonna be close. Do your favorite chemical reaction. My favorite. I don't have enough copper sulfate for that. Yeah, no. You know, I just went looking through my supplies. I don't have enough copper sulfate for that. What's the video? You mean the secret one that I didn't want to show? Ah, but you would like to know. Make some circuits using integrated circuits is winning, which is a good choice, if I do say so myself. And I did say so myself, so I do say so myself. That's because... First, what we'll need is this. A breadboard. Simple as it could be. Then, what we'll need is preferably this, which is a power supply, which obviously I'd imagine will be quite useful. Let me actually point it at you. There we go. There. Now, now you'll be able to know what power I'm using, but I will not. That's good decision making. Make it. Make xenon hexafluoride. Oh my goodness! No, the electrons. Let xenon have their electrons. All right. They tried so hard. Poor Xenon. Poor Xenon, honestly. I have got it. Alright, so let me show you why I think that making some circuits using integrated circuits is a fun idea. That's because recently I bought 3 kits like this. Now, what are those kits, you may ask? And that's a perfectly reasonable question. You see, first of all, I have this. These are just diodes, that's it. These are just diodes of varying shapes and sizes, except they all have the same shape, they all have the same size, and the only difference is the color. These are the, well, we're missing purple, but these would be the gay diodes. Yeah. If only we had purple, these would be the gay diodes. Now, next, these are in fact not electricity related in any way, shape or form, and these are just screws. That's just something I've been missing. And then we have this one, which is the actual fun one. Let me move my microphone even closer because this is the actual fun one. That's because no, my axe genuinely went dull. This is ridiculous. You can't have anything in this day and age. My goodness. A dull axe? What's next? My machete gets broken? Ridiculous. Hold on. Gay diodes on Pride Box. Yeah, 'tis the time. This is possibly one of the dumbest things I have bought due to retail therapy, by the way. But I've got it. This, I know it's hard to tell, mainly because it's a reflective material. Hold on. These are in fact chips. A variety of chips. Let me... what they are. They're chips. They're just different kinds of chips. That's it. That's what they are. So for example, we have a photocoupler, timer oscillator, dual op amp, I have no idea what that even means, audio amplifier, another audio amplifier, a third audio amplifier. We have a dual low noise op amp, we have a voltage comparator, dual comparator, PWM controller, that seems useful. Well, does it? Actually, on second thought, I don't know. Darlington transistor array. And what I think we could do today is we could just have fun with them. Just a bunch of integrated circuits. I have to go to bed. Good stream. Alright, good night, good night. Good night. It was nice having you here. Good night. Hi, the student Destiny. Hi, welcome. I suppose I should get my power supply going if we're going to... yeah, if we're going to do this sort of thing, I should get my power supply going. But another thing that's quite important is for us to turn on Firefox. There we go. We can make it a bit smaller in the side, in the corner, and that's because we will need to look up how all of them work. So first things first, timer oscillator, why not? NE555 timer oscillator, and we need the datasheet. Electricity is tied with integrated circuits. Y'all would really. I mean, listen. I see we're winning. If electricity starts winning, then I'm switching to electricity. I'm looking for the datasheet, obviously. Come on, that is ridiculous. PDF. Thank you, cheers. So this right here is the datasheet. For the component. That component being NE555 timer, which I'm guessing is this. Yup, it is in fact this chip right here. And as such, what we should start with is plugging it in. Probably also zoom in on it, shouldn't I? There we go. This chip right here, that is our NE555 timer oscillator. Hi the timing, welcome. Now, you missed make it opening a bunch of chemicals, by the way. No. Timing from microseconds to hours, just a monster. Yeah, okay, application. So what is the basic idea? What is the rough idea? We have a ground voltage, that's simple enough. Threshold, trig out resets, okay, those seem all simple enough as well. These are a bit confusing. I don't mean to be that guy immoral, but integrated circuits are still electricity. Alrighty. Yeah, description, okay. Each timer has a trigger level equal to approximately 1/3 of the supply voltage, and the threshold level equal to approximately 2/3 of the supply voltage. These levels can be altered by one of the control voltage pins when the trigger level flip-flop is set and the output goes high. If trig is greater than the trigger level and the threshold input is greater than the threshold level, the flip-flop is reset and the output is low. The reset input overrides all other inputs and is used to initiate a new timing cycle. Okay, coffee. Understood, alright? I need some coffee for this. Got it. He wouldn't snort it for me. Yeah, I wouldn't snort sulfur. That's not what I would... It's not good for you, you know? Sulfur is not good for you, in fact. Alright. Make the windows larger, you say. But then they might take up too much of the space. There we go, half and half. I feel like that's fair. Make it. Can you at least cut an onion? I don't have an onion. I don't have an onion. You joshing me in this economy? An onion? Okay. Capable of producing accurate time delays or oscillation. In time delayed or monostable operating modes, the timed interval is controlled by a single external resistor and capacitor network. In the unstable mode of operation, the frequency and duty cycle are controlled independently with two external resistors and then a single external capacitor. Okay. Make it. Electricity is winning. You really want me to research electricity instead of... Really? 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 Fine. Fine. That's fine. I understand. I get it. I get it. I see how it is. Don't think I don't. I see how it is. Let me switch back then into my not practical stream setup. There we go. Turn off the lights as well, and now sit down. Okay. Right. Let's then research some electricity, shall we? I'm still sitting in the same uncomfortable chair as I was sitting last time. I should really switch. I have a better chairs across the room. I just too tired to get it. Okay. Okay. So, electricity, you say? Library texts. If electricity is what you say, then electricity is what we will get. That's because we're looking for a specific textbook this time. Something I have read in the past, but I still need to brush up on. Hence why we should do it again. And that is the... I'm sorry, this is not what I meant. Resources, libraries, and then engineering. There you are. Electrical engineering, there we go. And then... Oh, which one was it? That's a good question. Not the textbook, only which... Because this is what we've been using last stream when we were researching. But what I'm looking for is different. What I'm looking for, effectively, is there was a textbook which went into the material science aspect of electricity and explained conductivity in a phenomenal way, truly phenomenal. And as such, I would really like to find it. No, this wasn't it. Electro-optics was it? That wouldn't make much sense. Unless it wasn't even... I could go to my old streams and see, because I've put the link, I always put the link in the description, but let me just see material science. I remember the book had some kind of title, material science. It might have been just material science. No. Material science for electrical engineering. That sounds like the jackpot. Does it? That seems like a jackpot. Electrical properties. Oh, that is a jackpot. Let's go for it then. Let's go. Ah. Yummy, yummy, yummy. All right. Bonding in metals, we know bonding in metals, we know this is all fairly simple. I know it may not seem like it because I'm using Dark Reader and as such it's just messing up all the images, but it is all fair and simple, Metallic solids possess special property that's similar to casual solids that make them easy and verify properties derived from the liberation of the valence electrons from control of individual atoms, allowing them to behave as highly mobile fluid that fills the entire lattice. What were previously valence shells, so basically, if I am not to be mistaken, then it's the fact that right here you get the valence electrons, which makes them less tied to the nucleus and such and such. Right, that's the overlap of metals, if I remember correctly. Oh, because these are also metals, I'm an idiot. I am an idiot. First degree previously valence shell orbitals of individual atoms become split into huge numbers of closely spaced levels known as bands that extend throughout the crystal. Yes, in fact. And then we have this, which is the graph I've drawn last time. These are the graphs. Viscosity, ability. Okay. I love these textbooks a lot. I really do. Bonds, thems be the bonds. That makes sense. How it arises from splitting in very small units. Condition bonds for infinite molecule. They're more shaded. Yeah. So if you have infinite molecules, then you would have a theoretically continuous energy band instead of discrete levels. Right. So far, this is all just what I described last stream. However, now it's time that we get into more difficult stuff. So, the band theory of solids provides a clear set of criteria for distinguishing between conductors, metals, insulators, and semiconductors. As we've seen, a conductor must possess an upper range of allowed levels that are only partially filled with valence electrons. These levels can be within a single band, or they can be a combination of two overlapping bands. A band structure of this type is known as a conduction band. So this. Right, it makes sense. But in terms of conductors, metallic conduction requires the presence of empty levels into which electrons can move as they acquire momentum. This can be achieved when a band is only partially occupied or overlaps an empty band. Or when the gap between bands is sufficiently small to allow ordinary thermal energy to supply promotion energy. Yeah, as I mentioned, this all makes sense. This is all just what I talked about last stream. Semiconductors, however, is where it gets interesting. That's because I'm sorry, I need to clear my throat a lot of reading here. Insulator, that's simple. In contrast to metals, whose electrical conductivity decreases with temperature, the conductivity of semiconductors increases with temperature. In many cases, the excitation energy can be provided by absorption of light, so most semiconductors are also photoconductors. Fun fact. Yes. Then you have N-type and P-type. That's important. For example, phosphorus atom introduced as an impurity into silicon lattice possesses one more valence electrons than silicon. This electron is delocalized within the impurity band and serves as the charge carrier for what is known as N-type semiconductor. In a semiconductor of the P-type, this dopant might be arsenic, which has only 3 valence, not boron? Oh, might be. I'm an idiot. Make it. Jeez. Shut up, make it. What amount of electrons? Deficiency in the whole electron crystal. Although the solid remains electrically neutral overall. This vacancy is filled by electrons from the silicon atoms. The vacancy helps in the allocation, so the charge carrier is effectively a positively charged hole, hence the P-type designation. Okay. Makes sense. So these are our bonds. And the difference is that in N-type... Wait, I'm sorry, what? N-type conduction primarily by holes? Electrons delocalize within the impurity band and serves as the charge carrier. N-type semiconductor. Wouldn't that mean that N-type would have more electrons? These electrons delocalize within the impurity band and serves as the charge carrier for those numbers. So shouldn't this be a free electron that is a conductor, not a... Holes? I must be misunderstanding something. I simply must be. One must do an electric deficiency or hole in fabric. The solid remains electrically neutral overall, as this vacancy is filled by the electrons from silicon. The vacancy of the is a positively charged hole. This is a bit confusing to me because right here it says that the charge carrier is effectively a positive charged hole in the P-type, but right here it says that holes are in the N-type. It would make sense for a hole to be in a P-type because, well, it's positive, right? Electrons are negative. Okay. P-N junction. When P and N-type materials are brought into contact, creating P-N junction, holes in the P material and electrons in the N material drift towards and neutralize each other, creating a depletion region that is devoid of charge carriers. but the destruction of these carriers leaves immobile positive ions in the N material and negative ions in the P material, giving rise to an interfacial potential difference, as depicted here. As this charge builds up, it acts to resist further diffusion of electrons in the holes, creating a carrier-free depletion region, which acts as a barrier at junction interface. Okay, this is important. This is just a single paragraph of text, but if I skim over this now, I'm gonna screw myself over for the entire textbook. So, when P and N-type materials are brought into contact, creating a p-n junction, that's simple, holes in the P material and the electrons in the N material drift towards and neutralize each other. This makes sense. You have one material that has too many electrons, one that has too few, and they come together, bring everything in. Creating a depletion region that is devoid of charge carriers, once again, makes sense in the middle. All the holes get filled with electrons, and all of a sudden you have no more charge carriers. But the destruction of these carriers leaves immobile positive ions in the N material and negative ions in the P material, giving rise to an interfacial potential difference. Right. That's because... Right. Oh, this makes sense. Because if you have silicon and phosphorus, I don't remember what color was phosphorus. And phosphorus, right? Very good, I at least got the P right. Then they together are neutral. Then if you have a silicon and boron, oh my goodness, got it right twice. And boron, all of these are also neutral. However, if you move an electron from this right here, then they are no longer neutral, only this removed a negative charge, which means this becomes positive. This got a negative charge, which means this becomes negative. However, this is where normally you would have an N-type, which means that in a p-n junction, you have a region with, that's the N-type, then a region, that's the P-type, then right here you get the depletion zone, where this is actually becoming a tad more positive, and this is becoming a tad more negative. So we're... This is becoming a tad more negative. Okay, that makes sense. It gives rise to a potential difference, right? So for a negative, for example, it would like to be pushed. So a negative, for example, yes, would like to be pushed this way, which means that if you have an electron going in, then it will try to go in, but the potential difference push it away. Okay, that makes sense. That does indeed make sense. Okay. Right. Good. I honestly was expecting it to be way more confusing. I know it was just a single paragraph, but that was a very important part of it, because from now on, yeah, we don't have to actually get through this. This is just formalizing a bunch of units. This is the funds again. I do have to say, this textbook is phenomenal. How was the day? And shall I feast on the door? My day has just begun. And please don't take my door away. I like my door. Well, let's say phosphorus then we have a gap that take from. Yup. And then there's Fermi diagram, right? If it is a Fermi level, Yeah, but just reference for the okay. So yeah, Fermi level. I'm just gonna quickly look it up because it's a bit quicker. Fermi level. I just don't remember. Was it the one where electrons ended? Is the thermodynamic work required to add one electron to the body? Mm-hmm. Quasi-Fermi levels. Oh, quasi-Fermi levels as well. Jeez, I forgot about this fun part. What's fun is that this is where the second video of the electricity series will actually lead to. Doesn't that look just fun? Huh? Aren't you all excited to learn about electricity? How it functions. Okay, so the Fermi level. It tells us something about chemical video also. More on this later. Alright, so not yet. Got it. This binary, not signed circuits indicate presence of mobile electrons in the whole material. The band gap for silicon and the actual spread of electrons would probably be. Let's look at a sample of p-type material, just for comparison. Note that for holes, increasing energy goes down, not up. So their distribution is inverted from that of electrons. You can think of holes as bubbles in a glass of soda beer. They want to flow to the top if they can. And then p-type materials, there are a few minor carriers. It was a child which arise from thermal generation across the band gap. Okay. Makes sense. All of it makes sense. P-N junction. Make an actual useful device. Let's take a piece of N-type material and a piece of P-type material and stick them together in this way we call P-N junction or a diode, which will be our first real electric device other than a simple resistor. This shows conducting and valence bands the same energy level of both P and N-type in different Fermi levels. It should be drawn with a constant Fermi level. The Fermi energy will always be the same for everything in device thermal equilibrium. It's drawn wrong Fermi level should be the same every device. I, by the way, also love this. This is also great. I can imagine Makeit's building's front door is still locked. It only was locked for a day, but still was really wacky that I got locked into my own apartment. Well, no apartment, but like building that my apartment was in. They just locked me in. It wasn't for my protection. It was to protect the outside world from me. Mm-hmm. Number says the conduction and valence bands are drawn relative to the Fermi level. A bunch of holes left. You would expect that in this absence of force given this way. They will start to spread out. The distribution is more less equal. Yes. Recombination. The place where this is most likely to occur, of course, would be the right at the junction between the N and P regions. Yes. In order to, we need to get another diagram. Let's go. Picture of the P junction. Oh, yes, so I understood it correctly. This process conserves charge, and if you could calculate the momentum as well. There's obviously some energy loss, but there's some vibrations here. There's not this. Oh, this is all phenomenal. As we remove more and more electrons in the holes, we are starting to uncover the fixed charges. Yes, that's what I drew here, where basically the N part has positive ions and P-type has negative ions. Electric field, of course, which field will rise as a positive charge will go to positive charge to negative charge. Yeah, so this is the arrow I drew. Oh, this all makes such a clear sense. I love this textbook so much. Yes. Diagram is for electrons. So when an electron moves from the right hand of the device towards the left hand side, it will have to move through an electric field, which is opposing its motion. But our band diagram has the sudden shift through this continuity in environments. A moving electron can't suddenly change kinetic energy. The band must continue to cross p-n junction. We can't trace or make a connection between the bands. It has to do some work. In other words, the potential energy for the electron must go up. There is a shift in potential energy as electrons move from right to left across the junction. Whose idea was it to call the absence of electrons holes? I don't know, but it makes sense. It makes very reasonable sense. Because, I mean, they are holes. That's... I think that's a great name, honestly. Building potential majority of holes period. Yeah, okay. This all makes extreme sense. So when you have a diode, then if you have an electron going right from N to P, then you have a potential that is working against that electron, which means electron walks up to the, electron goes to the depletion region, and then it slowly gets pushed away. Right. Whilst if an electron is going this way, it's going to the depletion region, and the potential works with it, not against it. And that's why if an electron is going right, it will go back, but if it's going left, it will go on. And hence what you get is flow of electrons that only flow one way. Isn't that convenient? Oh yes, it is. Potential barrier which prevents the kind of... yeah. Not too hard to figure out, just look at figure carefully, remember from equation, and then we have all the equation. This was quick. This was really quick, I gotta say. I wasn't expecting the concept of a depletion region to click in this easily. Let the magic smoke flow out of these diodes. But this is really good. Alright, this all makes sense. Now, the only question that remains is what's the Fermi level? Because even though Fermi level has been used there, I don't know if I missed an explanation or... because it did say that it was going to be explained later on. Required to add one electron in the body. The work required to remove an electron... solid state physics, right. In band structure theory, using solid state physics, Fermi level can be considered the physical energy level of an electron. There's just a probability of being occupied at any given time. Oh, that's simple. That's really simple. Yeah, so like the place where okay, yeah. Okay, that is actually really simple. That is really simple, in fact. Good. That is good. Now the only thing left is the conduction and valence zone thing. I would like to have a good understanding of it because it's important. Conduction band, valence band makes sense. So okay, so the gap, right? Wait, but then the Fermi level was in between them. This is the valence. This is a conduction. Oh, that's a bit tricky. Actually, hold on. Which chapter have I missed? I remember there was one chapter that ended off with this. There we go. The scared gamma gap was actual spread of electrons would probably electrons figure. Let's look at some of the material comparison. Okay. Oh yeah, because in the middle they would cancel. Right. No, that also checks out. I think at least. And therefore I am. I think, therefore I am. I like it. I do like it. This really got me in the mood to actually get a move on the battery video, because the quicker I'm finished with the battery video, the quicker I'll be able to work on the wires video. So really quickly, let's just set up some kind of animation. Extension of -2 because it really likes pulling electrons close. If oxygen bonds something, if we break that bond... Oh yeah, well I need to rescript this in its entirety because... Mind. Let's look at water. Also, this right here will be important. Here we have the rules, and now let's think about water for a second. So what do you all think of water? If we have water, oxygen is more electronegative than hydrogens, which means it should pull the electrons from, which means hydrogens should have +1, +1, and oxygen should have -2. Am I correct or am I wrong? I'm looking for oxidation states. -2 +1 +1. Simple. Alright, there we go. I've managed to get it for the simplest, the easiest mode. I'm in customs right now. We're back to Americas. Like just a standard customs thing, or did something happen? Unfortunate. Wait, I don't travel outside of the country even, so is that like a standard thing or not standard thing? Standard customs. Oh, okay. You got me really worried for a second, Stump. Really, really worried. Just leaving Europe. Oh, I see. I'm sure, well, you can always come and visit in the future, you know? It doesn't have to be a complete end. In the future, I'm certain you'll come visit. In what have we got? Oxygen. This looks like chemistry, yeah, it's for the battery video. Ah, my bones. I need some new ones. And then we have hydrogen and oxygen bonded with 2 electrons between them. Oxygen is more electric than hydrogen, which basically translates to it pulling electrons harder, which means that electrons are actually closer to oxygen than to hydrogen. And so if we ignore bonds for a second and just using the power of our imagination pretend that ions, then oxygen would have two more charges and hydrogen lose negative charge each, resulting in a more positive charge. Right. Okay. As such, we bring the bonds back, the oxidation states in water. Let's make the -1, 2, and negative. Nope, +1, -2, and +1. There we go. Oxidation states. Now let's find I feel like 2 more molecules would be nice to really solidify the understanding. Now what would be 2 molecules? We need something that's... Hold on, let me look through my boxes. What do I have? Something that we could do. Damn it, almost everything I have is a salt. Okay. I've got potassium hydroxide and urea. Those should be fine examples for, okay, potassium hydroxide oxidation states. But before we do that, let me actually try to work it out myself. Table.com. So basically, salt and battery. So basically, potassium. There you are. There we go. So potassium has 0.8. Means 0.82. Oxygen is obviously high, 3.44, and you are 2.2, which means both of these should come in, which means potassium should have +1, -2 +1. Let's see if I'm correct. Would be nice. I think I am. I think I in fact am. Good. That's good. Okay. Let's move on to, because the soul is the easiest one because I can. And want to something a tad more. Actually, this would be a pretty funny bit for a video where basically like where basically I'm sitting in, oh shit, that would be a funny bit where after the Ria example, right, I'm trying to come up with a fourth one, and it just cuts to me in my kitchen being like, I would give you another example, but every other chemical I have is a salt. Based on a real story. Speaking of, actually, let's start animating this. No point in wasting time. No point in wasting time at all, in fact. Now, oxidation state, and let's delete all of those. Not needed. Right. Oxidation states, perfect. And then what we'll need right here actually is we will need a what? We will need a chemicals. That is what we will need. 0. Wait, why do I have scale? That's what the heck. Alright. I think this should all be reset now. Seems reset, good. And now let's do 70. This will be our intro. What we could use, in fact, actually, I suppose would be some kind of chemical environment, which fortunately I have in my file called Walter White. Alright, let me just grab a... Do I want to grab the whole thing? I have no idea what I'm doing, it's great, but... Yeah, why not? A tad bit too cinematic, we don't need that much exactly. Although we could use some kind of... Yeah, we could use some kind of, you know... A bit of flair. A bit of... you know... Just a bit of... Just a bit of... Alright, I need to angle this properly so that it will look good. There we are. Hi, I couldn't, but I'm going to try again later anyway. You know how it goes. What? What did I miss? What could you not? Don't let the haters get to you. Is this empty on the inside? No, it's not. I knew it. I just gosh dang knew it. No keyframes. That's good. Perfection, perfection, perfection. What is this? Oh, yeah. No, we don't need physics. We don't need physics. I forgot that's what I was using it. The background is going to be blurry anyway, so we might as well actually... This clashes too much. No, it doesn't. There we go. Perfection. Now. Perfection, perfection, perfection. Focus. Right. And let's have it be a 1, or maybe even a 0.4. Second fucking customs. Yes, you joke about the bombs too much, you know? You've overdone the jokes on the bombs, I think. Okay, now let's make a water molecule and let's see how it will stand. So we'll have oxygen, which will be red. And then two hydrogens. The only difference being that, well, actually we can then disassemble it, add in the bonds and do all that jazz. Yup, I suppose. Now let's see how it looks rendered. I do believe it looks pretty fine. The only problem is that the angle is kind of garbage. So, no harm, no foul. We can just move this a bit up. Now let's see. How does it look? I'd say this is fine. I would say this is fine. At least now I have a pretzel. I like it, Stump. I like it. The silver lining. That's great. Now, with that in mind, and then, alright. So we turn all these off. The cube, which is the volume. We turn this off like this. Perfection, and then we want all of these to appear. They can actually appear over 50 because that should also be fine. And then 30, 40, 50. Perfection. I feel like it should be fine turning on motion blur because we won't really have... Let's... Wait, no, start a frame. Yeah. Frames oxidation states. Is this all good? I think it is. Let's do 64. Alright, neat. I'm back to the scripting. So let's question on 1 second. It was pretzel shell bread and then way over salted pretzel. Never had myself pretzels, so I wouldn't know. Aren't pretzels just bread anyway? Okay, pardon my lack of cultural knowledge, but isn't pretzel-shaped bread just a pretzel? So here's the molecule. Don't think we're all sprinklers on one side. Oh yeah, like sacrificing the actual enjoyment of food for the sake of it looking different. Ugh, gross. Potassium and the bonds between potassium and... Oh, that will be important later, yeah. For now, it isn't important because potassium has this right here. And so when it bonds with oxygen, it bonds as a single bond, yeah. But the more bonds, the trickier it will get. Again, bonds and electrons that will come up. Now, winning with electronegativity, pulling the hydrogen and away from resulting in +1 -2 +1. So, there we go. Next, let's move on to something larger to truly test the skills. Something like yeah. I'm looking for... Actually, I should try it myself first, although it's gonna be quite painful, because right here, this is carbon, right? Carbon is a triple bonded. Oxygen, carbon, 1, 2, 3, nitrogen, nitrogen, hydrogen, 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 hydrogen. So, obviously oxygen has the highest electronegativity. I don't even need to check. Like top right corner, obviously. Nitrogen, carbon, that makes sense. Okay, so oxygen will be pulling away from oxygen will be pulling away from carbon, nitrogen will be pulling away from carbon. Everyone pulls away from carbon. Nitrogen also pulls away from hydrogens, which should mean +1, +1. Hold on, +1, +1, +1, +1, +3, -3, -3, +1, -1. This is a double bond. It's a double bond, -2, +4. Let's see if I'm correct. Okay, that's oxidation states of the... do you really not have like, I'm just looking for the oxidation states. Oxidation number. Is that really what I need to? Oxidation number. Oh, lovely. Wait, is that right? Yes. Oh, lovely. Oh, I love you, chemical aid. Or as I'll call it, chemical laid. It's terrible, I'm sorry for that. -3, +1, +4, -2. I am amazing. I am incredible. I'm not a chemist. I'm not a chemist. And I got that right. I got that right. And I'm not a chemist. You should all bask in my glory. Honestly, it's honestly incredible that I let you watch for free. This is good. This is actually really good news. This is really, really good news. Because that means it's consistent. It works. Urea. Oh. Well, I'm creating coffee right now. On the other hand, I won't have time to do much today, so I shouldn't waste a coffee all day. I'll not be able to do anything for over a week now. I mean, waste the coffee. Chain. Because anything that contains any carbon is a carbon chain. Legally a carbon chain. Okay. Bonded normally. And right here, I'll the brightness every single atom to represent its electronegativity. That's oxygen. Highest, so it pulls electrons away from nitrogens also away from carbon, so carbon and hydrogens, resulting in hydrogens getting +1, -3, carbon getting +3, and oxygen -1. Correct? Oxygen, we actually have a double bond, meaning that oxygen isn't pulling away 2 electrons, only 4. That's getting 2 more normal. So and carbon is losing 4 more than it would from that. So plus 4 charge. Okay, there we go. We've got them water. Carbon monoxide, dioxide, acid, and carbon are not carbon chains. Well, not with that attitude. Well, I just put it up and tapping feels like a fever dream. Why? What happened? Artistic Panzer, you good? What are you going through? Okay. What's next? What's next? What's next? Her up. In water, we've got oxygen and hydrogen bond like so. So we want them to move away, and then we want to create like a bond. Should I do it using, well, using geometry nodes would be the best, probably. So I'm gonna do it using geometry nodes. Oh, this is actually gonna be quite tricky. Slow response time, I see. Oh, this is gonna be mighty tricky. But also might be a bit fun to make. Oh, this is fun, okay. So basically, here's what we will want. 2 UV spheres like this, of varying sizes, varying lengths, and then a cube that will be our bond. Now, we can just leave it there because it doesn't really matter. Bonds, that's what we're gonna call them. And here's the basic idea. We would like to select object info, these two right here. And then now, how should I tackle this? Feels like something I could maybe do with a bounding box, but I don't want to overcomplicate too much for no reason. Ideally, I would like to make a circle around this. Well, making the 2 donuts, for example, that would be easy. But I would rather do it using a curve. Circle around first one, circle around second one, then we need to somehow combine the curves in a smart way. Should I make my own video, make it? Yeah, why not? Yeah, torus doesn't exist. Let's do curved circle like this. Then was it full curve? It wasn't full curve. It was the curve dumping. The curve line. Oh, curve to mesh, right? Curve to mesh. Yes, okay. Now transform to this location. There we have it. Radius can be permanently a bit smaller. That's because we can have set material, and that's gonna be bond. James, the Bondulance. There. So that's a start. We move it to this one. Now, it's easy for me to make the curve circles properly. And that's because what we can do is we can just take this, separate it XYZ, and we can pick any of them. And then all we need to do is just normalize. Right, so for example, if now instead of picking the top one, we pick this one, we get a proper ring around each and every single one. Which means if we do math and then what material only math, and then add just a little bit, we get an outline, which is what we want. But now how do we combine it with... How do we combine it with the other one? That's a good question. Well, Blender geometry nodes interpolate 2 curves together. Is this something that someone ever asked? Wait, that actually might be something that the node is for. Hold on, interpolate curves. That's because what we will also have is then the second one. Yeah, so right here, we actually want to move this circle like so. Join geometry. And that's because we also want the other curve to work in the exact same way. Perfection. An interpolate curve would be nice. What would be difficult? The position of the first root control points on new generated interpolate curves. Okay, first of all, question. So you've done it like this, where you have the factor that mixes in between the position. Wow, that's a bonkers setup. All right. Sample index. That makes sense. So what we would basically like to do is we would like to... That's tricky. That's tricky, really tricky. That's tricky, really tricky, because our new curve will have one less... Wait, will it have one less point in it? So basically what we want to do is we want to take the curve points and create new curves so that instead of going 0, 1, 2, 3, 0, 1, 2, 3, it's going 0, 1, 2, 3, 4, 5, 6, 7. Here's what we have. And here's what we want. And this should make a fine bond. An even better one would be without these double points right here, without doubling them up. I could do it using also some more proper maths, I suppose. Oh, hold on. Curve. Let's see how the curve tools that we have access to. We have stuff like points of curve. You have a point index within the curve. $100%. Oh, Jesus. Oh, okay. Curve to mesh, get the point. We could actually turn them both into mesh, or maybe then it'll be easier to access. Maybe. I could just do it manually. I don't know why I'm trying so hard. Good question. Okay. Makes sense. Not combining. Shucks! Shucks. I could do it with maths, but I really don't want to do it with maths. That's because technically we only need like 4 points around each. And considering how we're doing spheres, those points should be trivial. get. Could also just do it manually, like a normal person. As if. Okay. Let's do the maths. Not get, only set, actually. Individual points of instance curves, yes. Versus segment curved points. We're doing realize instance and then set position. Curved points, transfer attribute position. Oh, jeez, that's wacky. Okay, so you take the Bezier, you change it to points, and then that is really quite wacky. You can manipulate your project and contain the same data. Wait, so set position, hold on, would set position actually work on its own? Quick question, because that would make sense. Set position is made to handle this kind of data. So if I do index, for example, and if I do combine XYZ like so. Beautiful! Oh, absolutely beautiful. That is absolutely beautiful. It might be idiotic, but index switch with vector. That's because, oh, it feels so good when I have when I think something's the case and it turns out to actually be the case. Oh, that is always such a nice feeling. I think there are 4 of them. Okay, there may be in fact more than 4 of them. Resolution 32, okay, let's do resolution 8. Oh, then you can manually set up, oh, right. What? Define using 3 points, that checks out as well, okay, no, radius. Resolution 8, is that because at the end we can also always resample curve, like... Or just a single curve? I'm sorry. Well, that's tricky because I don't want to deal with 32 of them. I would rather do it with... Oh my goodness. Blender geometry nodes interpolate a curve this time, not 2 curves into a single one. Not 2 busy curves on the interpolation. Yeah. Let's say that you have something else originally you would like to make smooth it out. Because I refuse to believe that this is smooth. I'm pretty certain that if I do curve to mesh like this, and if I use this as a profile curve, it's going to be, yeah, exactly the problem I'm having. Exactly the problem I am having. That's what it is, okay. Overall normal. I don't mean that kind of interpolation. I mean classical interpolation. Lofting. Is that the name for it? Was... Nope. No, Blender API. I mean, I suppose we could just like try with this. New curves on points by interpolating between existing curves. Plural. Why plural? In this case, I don't need plural. I just need singular. A curve to interpolate. Just make smaller set of original curves to make editing easier and faster, also generating high density curves for the viewport and final render. Base curves that new curves are interpolated between. Optional up vectors, okay, splits a guide to separate groups. No, the positions of the first root control points of new generated interpolated curves. So this can in fact interpolate between multiple curves. I really would kill for an example. An example usage would be just moi. Instead of points. An example would be just moi, because the position of first root control points. Guide curves. Do I just chuck in the guides? Split guides into separate groups. So that would be like a different attribute for every single one of them, but then that would mean, correct me if I'm wrong, that this should be just unplug this temporarily. Need it. Store named attribute, and then this would be an integer, and it would be index, and then a 1. And an instance in this case, I suppose. And then capture attribute. Actually, maybe not index. Let's do int, because that's quicker, and might not run into problems then. Int integer, like so, attribute that points group. That gives us nothing still. That's good. That's good. Okay. New curves manipulate existing curves from a single group. This input can be used for generating hairpaths by stopping curves in different sections. Position of first root control points of newly generated interpolated curves. First root control points. I'm sorry, what the position? The positions. As a geometry input. What do you mean? Why? Can I just chuck in a cube over there? Because I'm losing it. Oh my goodness, the cube worked. Oh no. So okay, so it is what I think. Well, it's not quite what I think it is. It's way worse. Position as a... I'm fine. Mesh line with 2 of them. Start location. End location? Plug it in. Oh goody. We don't need to move it anymore. I suppose we don't want point group ID anymore. Anything. I'm losing it. The guide curves with interpolated curves. No, mixes the data from multiple guide. Index of the curve with the largest weight. So we just want to pick the one that has the largest, closest weight? I really wish I has an example, to be honest. I don't want to watch a video on it because, well, content stealing. I'm sorry, do I not understand what the word interpolate means? Unless it's interpolating differently. Unless it's interpolating, oh, there's one possibility. Oh yeah, unless it's interpolating like that. In which case we would just get two circles. Which means we're back to manually well, but I mean interpolating like... There's one thing that still throws me a bit for a loop. That's because interpolating the curve itself feels like something Blender could do. It can do subdivide curve. Divide curve. Is that what I need you to do? So if we do 4 and 4. Well, no, you're subdividing it. By the profile curve, it won't really give me much, will it? Yeah, the problem still remains. This is a very curious problem. Yeah, you don't know what I know. Okay. 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 If we have 4 of them, here's what we can do. We can start with this. Then we can position them so that they are facing each other. Then we can what we would need to do is we would need to somehow make this connection and disconnect these. And then we would have a whole thing that we would need to then interpolate over. Except then it wouldn't... Well, I mean, no, that would work actually, yeah. What's more, if we rotate them towards each other, then that means every single time... Oh, this could work. So rotation, align Euler to vector. I never remember which way you're actually supposed to plug it in, so here goes nothing. Right, listen, we need the bond to be actually visible, so this is wrong. Good. I absolutely never remember how to set it up. Oh, there we go. Done it. Good. That's good. That's really good because rotation 90, no 45. Now it is always facing, sweet. And then what we do is we just copy the setup at the top, plug this in, and plug this in backwards. Now they are always facing each other. Perfection. That's because what we'd like to do now is then the curve destroy a connection between 2 points. I have no clue how to actually. 2 points of basic curve, yes. And geometry nodes, obviously. Geometry nodes. I'm spending so much time on this, it's not necessary. Trim curve, that sounds tempting. .75 should give us a perfect one, actually. There we go. That's better. Now, all we need is create a curve from points. Groups of grid fence layers into one. This and then resample? Nice. No, that's great. That's good. Curves, operations. Yeah, this won't work because we don't have a connection there. What we could also do, now that I think about it, is we could do it in a smarter way. Yeah. We could do it in a smarter way because instead of trimming it, we could take the points and then we can do curve line like this. No wait, not curve line, only... Hi the Bedsig! Hi, welcome! Could quadratic base, yeah. Resolution, perfect. That's because we can do resolution 8. Start, middle, end doesn't matter. That's because we will, in fact, we will, for example, so set position, and then for each one of them, we would like to set it to be on the position of these points. So I repeat zone, I suppose. I don't know how else to do it. Actually, no, we have a set position. We can do it in a smarter way. Hi, David. Hi, welcome. Get position like this, and then for each point, like this. That'd be nice. The answer is no. All right. So close and yet so far away. Curve, read, undo positions. I suppose I could do that with capture as well, but no. No, I would rather... I'm losing it. Dimension, I could have just done all of this manually. I don't need to do it automatically. This is just my obsession. I would probably be done by now if I didn't do it automatically, if I did it actually manually. Realize instances like this, and then attribute position. Now instance on points, and let's see if this will work, because if this will work, oh yeah, right, sphere. Perfect. And if we do set position and set it to the position, nothing changes. That's good. That is good. Which means right here we do in fact end up with points. Now the question remains, are these points proper? That is, do they go 0, 1, 2, 3, 4 the way we want them to go? And only one way to check, I suppose, and that would be to... I'm melting, please now. Why are you melting? Not again! Yes, good. Okay. Yeah, I'm gonna get 40 in the afternoon. Oh, jeez. Oh, that is terrible. Oh, I wish I could do something better, but whether that's another god's jurisdiction, you know? That would be pretty rude of me. Nothing I can do, unfortunately. What I wanted. Attribute. Hold on. Attribute statistic. Actually, this may as well. Well, selections. Right. So if we do index. Hear me out. If we do icosphere, right here, join geometry and just another icosphere. This time a larger one. That's good. what I would like to do is I would like to move it onto these points. And in order to do that, what we can do is why is attribute a variable? What? Oh, the only variable vector. That's neat. Okay, so a vector. That's your attribute. This is the attribute you're getting it from, and then compare epsilon 0 and then integer like this. Mean. I am a genius. Holy shit. Oh my goodness. Okay, got it. Got it. That's good. That's good. That's good. That's because right now what we can do is we can do what? That's actually a good question. Well, we basically have I don't know if index switch. No, index switch is not gonna work like that. But can I just plug in? Wait, actually, can I just plug in the position right here into the position right here? There's no way that would work, right? Oh, it wouldn't. But this allows us to capture the specific attribute, which means we compare the index, and depending on the integer, we capture that specific position. Come on, you can do it, buddy. Leaving yourself 8, and then selection this compared to the index, actually the same exact way. Plug it in right here. Then the mean becomes the position. Just plug this in. Oh yeah, right, because this has to obviously go to, no, not join, only to geometry. And the geometry input has to go right here, and then the input has to go like this. Yeah, and then maybe 7, no, 8, 7, connect, just connect, just connect! Math, truncated modulo of an 8. Right, iteration right here. No wait, index. None of, I don't know which one, but 9. 8. Yes, my goodness, that took a while. Right, and so what we end up with is this, which is in fact a curve. Actually, I'm pretty certain we can increase them some more to like loop around to have it be a bit more. Yeah, okay, great. Resample curve. Now all we need is just to clean up the curve. Just in some way make it make sense. Only spline circle. Oh, I'm losing it. I'm losing it. Give me. Yeah, no, we don't need read. We need operations, and what we need is not trim. Only wait, what am I doing? I don't need that. I can just make circle, curve circle with 8 resolution 8 and just plug this in. Okay, good. That's good. That's good. This is good. This is good. That's because right here now we have a value which will be 0.44. We can plug it into the maths and then we can make them bigger or smaller. It does get a bit wacky at times, but what doesn't? Now all we need is just like, well, interpolated normally would be the word, but in this case it's clearly not interpolate. We clearly do not interpolate it. I don't know. Be like resampling or interpolating, but neither of them works. Subdivide curve, maybe, but subdivide doesn't really do much. So subdivide isn't that either. I just having fun. Oh no. Water or something. Go. Quick. I mean, 40 degrees is madness. It really is. Wait. Oh. Alright, that might be a bit much. This is almost it. This is almost it. First of all, this right here, let's give it like higher resolution, something like 32. A bit smaller radius. And now you can have way higher count. Just stop dying, like, no! That's bad. That is in fact bad. Maybe the problem is that there are 4 points. That could be it. We could change it to be a 3, a 3, and then a 6, and then a 6, and then everything broke. Well, that's something. Oh, because truncated modulo, yeah, this is supposed to be 6, and this is supposed to be 6. Or I guess just... Wait, why can't we plug it directly? Oh, don't tweak it, make it. We trimmed it 75 and it has to be actually 2/3 instead. Okay. Close. So what we need right now is to test this out. See what we're dealing with. We get a triangle like that. Okay. That's something. Maybe 60? That'd be nice. It'd be nice if it was 60. That looks like 60, yeah. Now we replug this in. Everything gets messed up. Why does everything get messed up? This is proper. These go in. We take the positions. We truncate the modulo index 6. That's right. On the left, that's where it messes. Like, this is almost good. It sometimes works. It sometimes works, in fact. Alright, fine. Let's bring it back to a 4 and a 4. What happens if I bring it to a 5 and a 5? And right here to a 10? And then 0.8 on both of them. Oh yeah, and then the angle we also right, which means it won't be 60, it will be 30. It'll be 30. 36 makes sense because it's one. Shush, it does. Good. Now we decrease the scale of them, but then it's gonna create a bit of an odd shape. Unless this, well, yeah, this will only work sometimes. We need the scale to be small enough for it to actually function properly. Do we replug this in? It's broken. Is it like broken permanently, or is it just because it's... Oh, that's a curious error. Because right here we need a 10. Yeah, no. I'm doing this manually. I'm glad I've just wasted I don't know how many hours actually, an hour, something like that. I'm doing this manually. This is ridiculous. This is just straight up ridiculous. I am deleting this bond. Too much time wasted. Instead, what we're just going to do is circle. Bring it up. We're going to have it get the same rotation as the camera. Just gonna do it manually. Well, that was a fun adventure where I just wasted time. I want to get my flight. Well, good luck then, Stump. I don't know what to say to people who get on flights. I don't know. I don't know what's a proper way to say something, but good luck seems fine. Like so. Hundreds. The basic idea. We'll have this. We'll have this. Then we'll have this, and then this will move higher up. This will move more to the left. This will move more to the right. Then what we need is we need all of these to be just typical standard Bezier section, and then what we will need is for the circle like so. Perfect. And then there was another thing where like, oh yeah, right, we need another circle for this. And then geometry, wasn't it? Wait. Go shape. Nope. Oh, where was it? It's been a while since I've done this. Was it object? It might have been. There we go, yeah. let's do 0.1 for now. And then the second one, same thing, object, shape, 0.1. I really wish there was another way for me to control this, because then it would be much easier to animate, because right now what we need to do is we need to... Well, animating it will be tricky. Oh, never mind, we can just control... Bon voyage. Oh yeah, that too exists. The Bond kind of looks whack. Also looks whack because of the overlap, yeah. I suppose a volume would make the most sense. Of like emission strength 2. Emission color. Yellow like so. No. Let's do just emission. Maybe it won't look too whack. Let's rescale them back. Like so. Just have to make a bit smaller. Zero point 0.05 even. There we go, and then these we can change up a bit so they would look nicer. There we go. Took me long enough, I would say. I would say took me damn long enough. Oh my goodness, that really did take long enough. Okay. Okay, let's keep going. Might as well at this point. Plus 4 charge. And so those are oxidations. More examples, but there we go. Anyway, I think I'm gonna go. Yeah, today a bit of a shorter live stream. Certainly a bit of a short one. But we did a fair bit of work, we've wasted a fair bit of time, and I need to clean up around my office and work on the secret video. So that was fun. that was certainly fun. And for now, I suppose that'll be it. Thank you everyone so much for watching, and have a great day. Bye.